Okay, let's get started. So welcome in today's KeyShot webinar, where I will be talking about everything about material and render settings. Well, everything is maybe a bit of a stretch, but I will try to cover as much as useful information in this 1 hour session. So my name is Dries Vervoort, and I work in the Denmark office of Laxian. So, but before we begin, just a few details about this session. It will be recorded. The slide presentation that I have opened here will also be available after the session is over. The scenes, the KSP files of the scenes I will show will also be made available. The computer I'm presenting on is a 3-year-old MacBook Pro with a Intel Core i7 CPU. Just as a reference, if I run the KeyShot camera benchmark scene on this machine, I get around 65 frames per second. If you do have questions, just ask. So we have a chat box here. I will probably not be able to answer most of your questions here, but we will keep a log of them and make sure we get through them after the session. So yeah, let's dig into it. So this webinar is basically partitioned in 3 separate parts. So the first part is called To Bounce or Not to Bounce, where I will discuss the different types of bounces. In KeyShot, we have ray bounces, we have global illumination bounces. What do these concepts mean, and where should you harness each of those? Then in the second part, I will talk about harnessing material flexibility, and especially with some focus on using the enhanced materials in KeyShot 7. Then the third part, final part, is called What a Sample, where I will talk about the difference between material samples, render samples, and a few words on strategies on how to optimize your render quality, basically in a few different scenarios. Then a few closing remarks, kind of takeaway tips and tricks, and then maybe if there's time, I can handle some questions as well. So part 1, to bounce or not to bounce. So understanding ray bounces and global illumination bounces. So a few common issues that we see from a lot of customers is that they use the wrong lighting settings for their materials. So in this example here, I have a motorcycle engine housing where I applied a glass material to. And in the left example, you see that the glass material itself is looking nice, but the ground is totally black and has no color bleeding from the colored glass. And this is usually a telltale sign of a lack of global illumination. So if you're rendering glass, you need global illumination. On the right, we see an example where the ground is actually now correctly lit, but the glass itself is looking too dark, and that's basically because we're using too few ray bounces. So depending on the scene, you need to balance these two settings, but we will dig into this in KeyShot a bit later. So KeyShot has 2 parameters to tackle these challenges, and that's ray bounces and global illumination bounces, and they are both found in the lighting tab, as I will show in a minute. So ray bounces. What are ray bounces? Ray bounces should be increased for highly reflective or refractive surfaces. So if you have a lot of shiny metals or a lot of complex layered glass, that's where you typically need to increase that value. Then what are global illumination bounces? Basically, they are diffuse reflections between brighter surfaces. So if you have bright surfaces in your scene that are occluded, that are shadowing each other, then you typically want to increase the global illumination bounces. But I will also show an example of that. And in the case of glass, as we see here, you always need at least one global illumination bounce to have correct lighting for glass objects. So the product lighting preset, which you will find in the lighting tab in KeyShot, will actually work in about 90% of the use cases, if not more. So that's definitely a good takeaway message, that's a good starting point for most any scene. So here's an example focused on ray bounces. So if you have bright transparent materials, you typically want to have more ray bounces. So here on the left, we see an example with 6 ray bounces where the glass is looking a bit dark still. When we increase the ray bounces to 14, you can see that the glass object really comes to life. It looks much more realistic, much more appealing, and yeah, conveys the intent of the image really. Now, how many ray bounces you need really depends on the kind of material. So you see in this example that it makes sense to increase the ray bounces for brighter plastics, brighter transparent materials. But as the material gets darker, it the scene doesn't really benefit much necessarily from increased ray bounces. So in this case, I just used the same color of glass, but I just decreased the brightness. And because more light is absorbed, you actually do not see any benefit from this increase in ray bounces. Then global illumination bounces, as I said before, they should be used or harnessed when your scene or your object has bright diffuse materials, so bright white plastics, bright paint materials. So, and this may be hard to tell in this session, but you can see in this engine, which is lit by a HDRI pin from the side, that with 0 global illumination bounces, I have basically no lighting in these occluded areas. And that's because there's only direct lighting and no lighting is bouncing off from these surfaces onto these occluded areas. So this is pitch black now. If I increase the global illumination bounce to 1, then you can actually start to see some detail in these surfaces. So, oh, sorry. So with 1 bounce, you get a much more realistic look already. Now also here, there is sort of, a point where it doesn't really make sense to keep increasing this value. So there's definitely a point of diminishing returns. So if I increase the ray bounces, the global illumination bounces further to 4, you can see that this area is brighter still, so it gets more realistic. But as I increase these to 10, you really don't see much of an improvement, while the rendering will actually be slower. So it's a matter of, again, 4 bounces, 10 bounces. It's a matter of balancing the realism versus reasonable rendering time. So, and just as with ray bounces, you really want to look at your actual materials in the scene. If, for instance, all you do is render black plastic parts, then it really doesn't make sense to increase that value. So for dark diffuse materials, you can get away with less global illumination bounces. So you actually see no difference between these two. So let's just have a look in KeyShot where we set these things. So I'm going to open this same engine part. And now this is the default diffuse material. So if I go to the material library and I look for a glass, then I can drag and drop a solid glass material onto this engine. And maybe I want to decrease the saturation a bit. Now by default, a new KeyShot scene will start with the basic lighting preset. So that means that your glass materials will not look the way they should. So if I go into the lighting tab and I expand this general lighting accordion, then I see the ray bounces and I see global illumination. Now, if I click on this triangle or just the name global illumination, I get this global illumination bounces slider as well. So as I increase these ray bounces, you can see that glass material comes alive much more. So, but generally, I think a value of 14 is reasonable for many cases. But now, as in that early example I showed, I do not have proper light bounces on the floor. And that's basically because I need to turn on global illumination. And if it's a default ground, then you may also want to go into the environment lighting accordion and turn on the ground illumination. And now you get a nice lighting on the ground, as well as nice shading of the actual glass material. So, and in fact, if you turn on the product lighting preset, that actually already comes with the 14 ray bounces and the global illumination set to a value that is not 0. So this is definitely a good starting point. Now I'm going to apply a different material to this engine, and I will pick a white plastic. Just drag and drop it onto this engine. And I'm also going to import a plane. Double click on this plane and make it a diffuse material. And then I will go into the environment tab and just quickly create a blank environment. And in the HDRI editor, I will just add a small pin. So I will make the background black and have this pin decrease the size of the pin and make it much brighter. So now by toggling off global illumination, you can really see that it definitely detracts from the realism in the materials. So if you're working with bright plastics, you do want to have this global illumination on. If if I make this plastic darker, you can see there's much less of a benefit. So you really do have to look at at the makeup of your materials and then make an informed decision about which values to use. But as said before, the product preset is definitely a good starting point. So let's get on with this session. So that's just still a few basic words about the difference between ray bounces and global illumination bounces. If there are any questions about this, then please drop them in the chat box and we will try to get them covered and provide answers to you. So on to the next part, harnessing material flexibility, mastering materials for a wide range of use cases. So I have divided this into a few material types and the common issues that we see from users for those materials. One of the definitely the most common issues that people run into is in relation with metals. If you have a shiny metal in your scene, you have an HDRI that is quite contrasty with strong pins, with bright white pins. You can get into a situation where you have blown out metals. Now, this is not the worst example, but you can clearly see that the highlight of the HDRI on this metal part is completely white and is definitely blowing out the metal surface. So another example with regard to metals is that you can, in KeyShot 6 at least, it was kind of hard to get accurate and convincing anodized coating materials. So while this has some coloring in the metallic shading, in the highlight areas you can see that it almost completely desaturates and it gets very bright. This is not really how an anodized coating in reality behaves. So in KeyShot 7 we have some ways of addressing this, and anodized coatings are now much better to to visualize. So another problematic area is transparent transparent plastics, and people often run into this situation where their transparent plastic materials are kind of dull looking, not very interesting, and not accurate either, because if you look at this material, which is a plastic transparent material, you can see that the depth of the color does not really correspond with the depth of the actual part. So in reality, what would happen is if you have thin sections in a model, they should actually be brightest, and here it seems kind of the inverse. So, but there are a few options, not necessarily new to KeyShot 7, but there are a few other material types that are better choices than plastic transparent for these situations. So solutions in KeyShot in terms of material types, I have divided this into a few categories. First of all, I'd like to cover the measured metals with the anodized option that is new for KeyShot 7. New as well is the cloudy plastic material. which has control for transparency distance, the cloudiness, and the scattering properties of the material. Then we also made some nice improvements to metallic paint, where you now have fine control over the clear coat. In KeyShot 7, you can now actually texture the clear coat bump, so it looks like an orange peel on a metallic paint, or on like on a car paint, where you have this bumpy surface that is not where the actual the body panels of the car are not bumpy. It's just the finish on the paint. And you can also color the actual clear coat, so you can get some much richer colors than what was possible in KeyShot 6. We also improved the tune material a bit, and I would like to cover that as well, just quickly, and then show some application of solid glass for those transparent clips. So here's an example, the same set of clips as I showed in this example. So with the KeyShot 6 metal, you get these blown out areas for colored metals. Now in KeyShot 7, with the measured metals and the anodized options, you get much richer coloring and much more accurate color gradation. Like a real anodized coating will always have some kind of a color shift depending on the viewing angle, and it's subtle, but you can actually, I hope you can see that in the front facing surfaces like this blend, the color is more green, and as the surface rolls to the 90 degrees basically, you get more of a bluish tint. You can see the same here. This highlight, which is facing straight to the camera, is kind of purple pinkish, and as the surface basically rolls upwards, you get more of an orange or red kind of hue. So it's very subtle, but it definitely adds to the realism of the rendering. So with the measured metal, you don't necessarily have to enable the anodized option, but what they do have is that the presets you can now select, and I will again show that in a minute, is they will have a much more, they will have a more accurate reflection representation, you could say. So they will more accurately represent the real world uh, metals. So here's the same. So here I used a titanium preset for metal, and here is the same titanium preset but with the anodized option set. Now I will show in a minute the options, the control you have there to fine-tune the coating, but basically it's based on the physical model. And if you look on the internet for like titanium oxide thickness, you will probably find some table or graphic like this one. And if you enter these oxide thicknesses inside KeyShot, it will actually exactly match the colors you will find in these diagrams. So it's a very accurate representation of a real world anodized finish. So here's a yellow anodized titanium just by changing the thickness basically. Now another very nice material that is entirely new for KeyShot 7 is the cloudy plastic, and I really like cloudy plastic because it has a huge range of applications. So here I try to collect a few very distinct settings. So this bottom clip is basically an equivalent to a polypropylene kind of material, where you have the thin edges that are kind of glowing like you would or at least they are like bleeding some light on these edges, which you would expect a polypropylene part to do. This orange clip is more glass-like, so it doesn't have a lot of scattering or cloudiness. And this right part is almost looking completely opaque, but this is 3 times the same material, but just with some different settings for the different parameters. So it's a very flexible material. So here's cloudy plastic with a low cloudiness value applied to that engine housing part. So you can see you can very accurately represent something like a 3D printing resin, like a stereolithography kind of material, or a polypropylene, or some other technical plastic. And here's the exact same material, but with just an increased cloudiness. So it's a very, very flexible material with many different applications. And as with any material, you can texture most of those parameters. So here's a gradient texture that was applied to the cloudiness. So you can actually make a material fade from low to high cloudiness. And this is just a single image. This was not composited. So there's a lot of flexibility there. So cloudy plastic has some advanced properties as well. And the most important one perhaps of those is the scattering directionality. And this basically allows you to set how the scattering behavior of the material. So with uniform scattering, you basically, on the technical level, you basically push as much light through the material as gets reflected back. But then you can also change it so it is backward scattering, which means that most of the light is actually bounced back and is not able to basically penetrate through the material. So that makes the material appear darker. You can see that quite well in this bottom surface. So with uniform scattering, this is slightly brighter. With backward scattering, this gets dark. And then you have forward scattering, and then you can really light this material up, because now you're basically telling the material that the light can penetrate almost completely through the material. So you can really fine tune the look of your plastics using this more advanced parameter. But it helps when you understand what it's actually doing. So, but I will cover that as well in a few minutes. So next material is metallic paint, and here I have basically I have actually applied 3 materials that we ship with the KeyShot 7 material library. And there's a subtle effect here, but you can see now that the clear coat has actually a slight ripple effect to it. So there's a very there's the small scale bump map applied to just the clear coat. And the clear coat has also been colored, so you get a much richer color basically in your metals. So here's an example on an engine. This is a KeyShot 6 image basically with the white clear coat, or at least the clear coat in KeyShot 6 was not texturable or colorable. So it looked like this. Then in KeyShot 7, you can add some color and you get a much richer tone in your metallic paint finishes. So, and here's the same set of clips as I showed here. So these were looking kind of dull. Now, if I replace those materials with with solid glass, you get some more interesting material behavior. Now you can see that the thick sections like this, there's a lot of material here, are actually rendered very dark, while the thin sections are correctly rendered quite bright. So this is the physically correct behavior of how these materials react to lighting. So whenever I'm doing plastic materials that have sort of greater variation in thicknesses, I always default to solid glass or the dielectric material. So then we have Toon, which we've had since KeyShot 4, so that's definitely not a new material. But we made some changes here as well. So Toon can be really nice for illustrations and documentation purposes, because you get these nice, clean, basically line renderings of your products. And you have always been able to color the shadows, but with KeyShot 7 we introduced the ability to have some color in your shadows. So instead of being just black or gray, you can now have a color that matches the contour color, or that is maybe perhaps a complementary color. So there's some nice flexibility there as well. And then because it's a fully textural property now, the shadow, you can now add textures to it, so you get something like you can achieve something like a sketched look. So you cannot that makes it possible to present a concept as a concept and not as an overworked kind of proposal. So definitely nice. And this is just to show an even higher level of flexibility, where you can layer that material on top of like metallic a metal or any other KeyShot material, and then make like a fade by using a gradient opacity map. So now I will show some of those techniques and material types in KeyShot, and I will do that by using that clip. So here are those 3 clips. And first of all, I want to cover the metals. So I double click on this first clip. And I just change this default material to a metal. So for metal type, you have 2 options, color and measured. So the color is basically how it behaved in prior to KeyShot 7, so KeyShot 6 and earlier. So here, if you wanted, for instance, to do a chrome, you would pick a grayscale value and then find something that works well for the lighting environment. But you see, unless you set it like really dark and not very chrome-like, you easily get into the situation where you have these blowouts in the surface, and the product almost blends into the lighting environment. So an easy quick now in KeyShot 7 is to just switch from color to measured, and then in the metal preset you get, then you can choose a few very common metal types, and we have included some of the most common used in product design, at least. So you can choose, for instance, chromium. And now chromium, this will behave more accurately and reflect the actual behavior of a chrome part. So of course you will still depending on the metal, you will still have to tweak the lighting environment to suit the materials. Obviously, materials and lighting always go hand in hand. So, but I can now also switch this to a titanium, and now the coloring is basically embedded into that preset. And then I can add some roughness. Now, because it's titanium, I could potentially also have it in an anodized version. So I can just toggle on anodized. And there's a few parameters here. The most important ones are the film refractive index and the film thickness. The refractive index is basically the refractive index of the oxide of the metal that you are working with. So for titanium, that happens to be something around 2.5. These values you kind of have to know now. Now, if you look into, if you Google, uh, for instance, titanium oxide, then on the wiki page, for instance, you will you almost always find this value somewhere in the chemical properties. But if you do not want to bother with that, actually, when you go into the material library and you look for the anodized folder, then if you pick an anodized titanium there, they will actually come with that correct value. So the library has anodized presets for titanium, aluminum, and niobium, and those are, I think, the three most commonly anodized materials out there. So you don't really have to worry about this value. Now, now I drag a material into the scene, and if I now want to change the color, I just need to change the film thickness. And typically the thickness will range something between 0 and something like 200 nanometers. So this is expressed in nanometers, independent of your scene units. So that's how you set the color, and this will very accurately represent actual anodized coatings in reality. So for one clip, I'm going to right click on the surface and I'm going to unlink it. And then I will change this material into a cloudy plastic. So I pick plastic cloudy from the material type dropdown, and then I will shift left click, shift right click to apply, copy paste the material onto the other part as well. And just to speed up the rendering, because cloudy plastic can be a bit slower to render, so I'm going to enable the region. So here in the ribbon, I just click on render region and I drag out the window. And now all my CPU power is focused on this clip. So the most important properties here are transmission, transparency, distance, and cloudiness. So transmission, if I change this color, it's basically like working with glass. This is defining basically the transparency color of the material. So if I want a purple clip, I simply set it to something like purple. I typically uh, like to work with the HSV color mode, and then I will want to make sure I do not use too high a saturation. So I typically stick to something like 30% for cloudy plastic, and I do not want to use a fully bright color because in reality that just doesn't exist. So I use something less, and then I click OK. Now the transparency distance, just like with solid glass and dielectric, this basically defines the distance at which this color is achieved. So if I set this way low, you will get a darker and more saturated version of your transmission color. If I set this very high, maybe 100, I get a very bright and desaturated uh, color. So in this case, I'm going to go with something like 5. And then the cloudiness, with the cloudiness, you can really determine how cloudy, how much scattering there will be in this material. So this ranges from 0 to 1, but I would advise to stay away from the extremity. So I would not use a value of 0 and not use a value of 1, but something in the middle. But you can see as I increase this cloudiness, you get more of a diffuse, more of an opaque look. And now it's really a matter of balancing, especially these two parameters. So if I, for instance, with a cloudiness at 0.7, if I now decrease the transparency distance, then it will look more opaque. And if I make this even lower, it almost looked like solid plastic. So those two, actually those 3 parameters, transmission, transparency, distance, and cloudiness, those work kind of in unison. So you want to change those, change one of them and then maybe adjust another one to get the look you want, basically. And then if I expand the advanced accordion, you can basically set the scattering directionality. So if you set this to a negative value, that will make it backward scattering. So that will make more light bounce back instead of penetrating. If I make this positive, then more light will basically transmit through the object. And in this case, we'll make it look more transparent. Now I have a few scenes that I will provide with the presentation that more clearly shows the effect of this parameter. So next up is metallic paint, and again I'm going to right click here on the clip, choose unlinked material, double click and change this to metallic paint. Or maybe I will just look into the library and search for metallic paint and pick maybe this blue one. And again, shift left click, shift right click to copy paste the material. And again, I will use a render region. I double click on the material, and what we have now in KeyShot 7 is we have this clear coat accordion. If I expand this, I can see all those properties. So now I can set clear coat color. What I want to do usually is to pick a color that is kind of close to my base and metal color. So in this case, I may want to pick something that is a bit blue, going to purple. And then I can also change the clear coat thickness to define how strong that effect of that clear coat color is on the final paint, basically. And finally, what you can also do is you can add a texture to the clear coat. So clear coat bump. If I right click here, I can go to textures, noise texture. And if I scale this down a bit, can now see you get a subtle kind of bump effect just on the clear coat of the material. So if you want rich colored metallic paints, then these clear coat options are definitely very nice. And if you look into the library, into the paint folder, metallic, we actually have a subfolder here called candy coat, and these materials have actually been set up to show those new parameters. So they are a good help if you're unsure how to set these values for the best effect. So these have been set up to use a color clear coat as well as a clear coat bump. So now I do want to cover the toon just very quickly. So I will click on one of these clips and I choose toon, change the color to white, and I copy paste this material onto all these different clips, and I change the contour width to something else. What I usually do for toon is I go into advanced and I turn off contour width in pixels. Now it looks completely funky, but now I can set the contour width in actual scene units. I usually prefer this because now yeah, the relative thickness of those contours is going to be always the same. So the only thing that's really been changed here is that we now, if you turn on environment shadows, you can now go into the shadow property on top and change this into a color. Or you can right click here, and just like any property that has this thumbnail, you can texture it. So you can add a brush texture. And a trick here, something that I like to do for that sketched kind of effect, is to change the mapping type for the brushed to camera, and then really make the size very small. Now you can see you get this brushed effect. So if I now change the color, you get these nice brushed strokes. And then in size and mapping, you can also change the angle, so you get a different sketch direction. So that's a nice, a cool trick I often use to get that sketched look. Also, an example of this is included in the KSP file. So that's it basically for those new materials. So on to the third part, what a sample. So how to make sense of the different samples, different types of samples, and the render, and how to optimize the render quality. So what are the issues here that we sometimes see? So common is that rough metals like this ground plane are noisy, or that bright materials like this white plastic have this grainy kind of shadow, and usually or like often users experience that they take a lot of time or samples to get rid of this noise, but there are strategies to deal with these problematic areas. So here's an example of a scene that rendered almost for the same amount of time, but that looks much cleaner. You can see that, especially in this area, that the rough metal is looking much cleaner, and the shadow here is looking much smoother. So there are two parameters for this that are going to be essential in controlling that, and that is material samples and render samples. So the material samples can be found in some of the individual materials, while the render samples you set in the render output dialog. And the rule of thumb is to always increase the material samples first before you touch the render samples, the default render samples, because that will allow you to focus on cleaning up the materials that need the samples most. Now, there are a few things that just require more render samples, those samples you set in the output dialog, and that includes some materials like the ground plane, shadows on the ground plane object and the ground material, as well as measured metals. They just require more general samples. Shadows as well, shadow regions on objects, depth of field, motion blur for those working with animations. They just require more scene render samples. We have in KeyShot a few different render quality settings. We have maximum samples or time. That's a great general purpose setting that will work for most any scene. But in cases where you run into these noisy occluded areas, it can make sense to use custom control instead. So that can really be helpful in dealing with those tricky shadow areas. And then it can also make sense to experiment with interior mode, because it does have this quality that it has less noise than product mode. And I will show like how you can utilize that capability as well. There are some things you should definitely avoid, and that is, first of all, you should not crank up all the settings and sliders. So it's always best to not to start with high settings. Just start with the default, do a test rendering, perhaps see what the result looks like, and then maybe increase or change one parameter at a time and re-render to see if the change you made actually impacts the quality in a good way. So that way your scene is much easier to troubleshoot in case you're struggling with the render settings. So quickly going to show some of those samples, render quality options, and some strategies for strategies for optimizing the quality. Oops. So here is that clip scene, but this one is the materialized version. And yeah, maybe I'm just going to start from the original. And again, I will import a ground plane, and I will change the ground material just by double clicking here in the scene. I will change it to a metal just to match my example from the slides. And I will add some roughness to this plane. And this clip I will change into a plastic. Blue plastic is good. and this one I will unlink, and I will change the color here to something again, not entirely white. I never use 100% white for white plastics. Usually 82% brightness is just about right for any white material. Then I shift left click, right click to paste this over. And this final one, I'm going to unlink again and maybe make it a titanium, a rough titanium. Shift left click, right click to paste. And I'm going to make this ground metal a bit darker so it doesn't blow out as much, like this. So now you can clearly see here that this ground plane is very noisy. Now, one way to deal with this is to go in, if you were to render this as a final image, you could go into the options, and in the max sample setting, you could just enter a very high value like 500, 512, and then the rendering will most likely be clean and nice looking, but it will also take a significant amount of time, or definitely, or perhaps more time than you are budgeted for, or that you have uh, time for to wait on. So in this case, if you do intend this metal plane to be smooth without noise, then the first step should be to go into the metal properties, and here I can expand roughness, and you will find a samples parameter. Now, if I change this from the default of 9 to something like 24, you will see that these reflections start to clean up faster. So if I increase this even more, this will become even smoother. And I can increase this as high as I want. So at 64, you can see that this cleans up much faster. Now what's happening is KeyShot is basically now prioritizing the sampling of this material. So this will clean up faster, much sooner. Now, I would not go much higher than 64, and I think actually for this material it's already a bit overkill. So whenever I'm dealing with like these smooth metal panels or surfaces, I usually use not more than 32 samples, because it's also going to slow down the rendering if you increase this very, very far. Now, the white plastic and the basic plastic material does not have samples, so you cannot use samples to get rid of what is basically a shadow noise. So here the material samples will not work, and you will have to deal with it using the render quality basically. So I'm going to drag a region render again, and in this case I want to focus all the CPU time, all CPU power on this white clip. So if I render this with maximum samples, maximum time, they're basically the same thing. You just specify them differently. Here you set a render time to finish, and here you set a sample limit. So if I set this to 128, for instance, and if I kick off the rendering, then you will see that this noise will resolve, and with enough samples and enough time, it will definitely smooth out. But it may take more time than you have. So in that case, it can make sense, and I'm going to stop this rendering. It can make sense to use a different setting. And if you use, for instance, custom control, and basically for samples, for custom control, something between 8 and 16 works for most any product design scenario. So if I just set this to 8 samples and I don't change any of the others, if I now kick off the rendering, so it will render a bit differently in that it will basically start from the center, at least the center, in this case from the region, and then move outwards. Let me just close this again. And I'm going to actually really focus on this small area. So if I now kick this off, then you can see that now this shadow area is going to be much cleaner than it would be. It's going to be much cleaner, much faster than it would be with maximum sample. So in case you have areas like this that are heavily shadowed, that are on bright, diffuse areas like white plastics, it definitely makes sense to explore custom control. And then perhaps as a last remark, kind of a trick perhaps, it can also make sense to explore interior mode. So if I go to the lighting tab, then the bottom accordion, if I you will see at the bottom accordion rendering technique. Now if I switch this from product mode to interior mode, you can see that the noise and the characteristic of the rendering changes quite a bit. But what you can see is that with interior mode, these shadow areas clean up very nicely. It's almost like interactive custom control. So again, product mode, quite noisy. It will still be a nice image, but it will require in these areas a lot of samples and time. Interior mode, it gets smooth much faster. So definitely if you have products like these, it can make sense to explore interior mode. So one quick note here is that interior mode does not work with custom control. So if you now try to fire up the render, it will give you a warning that for interior mode, you either have to use maximum samples or time. So I realize our time is almost over, but I have some finishing remarks. So just a few quick notes here. Few recommendations. The product lighting preset is definitely the best starting point for most products because it has a good balance between ray bounces and global illumination bounces. Yeah, dare to experiment, dare to use interior mode even when you're not rendering interiors. And definitely explore the new material options for metal, especially the anodized option for metal. Dare to experiment with cloudy plastic, figure out or experiment with the different parameters and perhaps try to match some physical examples of clips and plastic parts you may have laying around on your desk. Um, so, and then as far as samples go, increase the material samples before the render samples because that really allows you to focus the samples on the materials that most need them. Um, Maximum time or maximum samples is a good starting point. Uh, if you are running into situations where you have a lot of shadow areas, it can make sense to use custom control or interior mode. So that's basically it. I know we are out of time, but I do have a couple of minutes for questions if there should be any. Let me just have a look. So you have a look at the questions. Please elaborate ground illumination working and other use cases. Yeah, so if I reopen this scene, then in the lighting tab, so if I switch this to basic, it does not have ground illumination. If I switch this to product, it does have ground illumination. And let me change the material here to something like glass. So what ground illumination does is it illuminates the default ground. So it only affects the scene if there is no other geometry used as ground. So that means if I, for instance, import a ground plane, then this will always be affected by, in this case, a glass material. So here, this ground illumination does not really resort any effect in the scene. So this setting really only makes a difference when you are working with the default ground material. Sorry, the default ground as it is set in the environment tab. So also the same applies for like ground shadows. These really only affect the default ground when there's not actually any geometry to serve as the ground. So I hope that answers that question. Here's another one. Could you show an example of rendering a diamond? I do not have a diamond scene readily available, but if you look into some of our previous webinars online on YouTube, you will find a dedicated jewelry rendering webinar where I cover the rendering of diamonds quite extensively. Also, if you look on the download section on our website, you find the accompanying scene that went with that webinar, and it has a nice pre-configured like diamond ring setup. So definitely check that out. Just see, maybe I can tackle 2 more questions. Let me see. Please show how to make the inner part of the clamp glossy and the other opaque are textured. So I guess the question here is how to basically vary the roughness, or maybe have entirely different materials for the inside and outside. Now that's definitely tricky, and I would say, so if I just make this diffuse, so maybe you want the inner part. Let me just turn on performance mode, so I do not have quicker rendering. So maybe you want the outside surface to be metal and the inside to be white. Now the best advice here is to actually do the surface separation in CAD. So you have 2 distinct surfaces because unless this model would be model with polygons and have proper UV mapping, it would be very hard to separate those surfaces out. We do have something, if you, for instance, and I'm going to go into the material graph here. In this case, it may work out because, yeah, some of these surfaces are convex or concave, so I can maybe use, like if I right click here in the material graph and add a curvature texture. If I press C to preview the texture, I can perhaps use these properties to select out those surfaces. So you make this a very small cutoff value, and this is really more of a hack, really. But I could make the negative curvature, for instance, black, and zero curvature black as well, and then the positive curvature white. Now I'm basically, this is kind of a fake approach, but it may just work for this particular model at least. So now I'm basically creating an opacity map, and what I can do now is maybe add a material as a metal, add it as a label, and then use the curvature texture as an opacity map. And now I basically have metal covering the outside and the plastic covering the inside. So if I now change this diffuse to something like red, it's a bit funky because of course the opacity map is not completely black and white, but you can get something that kind of works. But of course it does come with a few disclaimers. This technique really only works relatively well for this particular geometry because it has this concave convex separation in the geometry. But it's perhaps a technique you can use if you have similar geometries. Please show the gradient rendering where half is stone and the other is plastic. So that's actually pretty similar to what I did here. So in this case, I will actually also mention that in the library, we have those preset toon materials. So if I look for the toon folder inside textured, if I drag and drop, for instance, toon sketched onto the clips, then those actually have been pre-set up to have that camera space brush texture. And let me copy this over to those other parts. So maybe I want to have a fade here from metal or something. So I can, here again, I would go into, if you have KeyShot Pro, I would go into the material graph. And here I want maybe to fade it to metal. So I right click, or maybe I just look for a metal here, a anodized rough aluminum. So I just dragged it into the material graph and I apply this by dragging and dropping onto the base toon material. So now the metal has become a label and is completely covering my toon material. What I can do now is I can right click in the material graph, add a texture and pick a color gradient. Without attaching it to anything, I can just hit C to preview the texture. And now one thing you want to adjust first, I guess, is the scale inside the color gradient texture. So the scale is going to correspond you want to correspond with the size of your object. Now I'm not sure. So these clips are 85 millimeters. Yeah, if I change this to 40, you now get the gradient from the first to the last stop, basically spanning 40 millimeters. Then with move texture, you can move and rotate. Yeah, it's more like it. So now you have basically this gradient from black, completely black to completely white is now spanning 40 millimeters. Whoops. So if I change this to 60, it's going to be like this. Then I can move it, and you can see these are 3 duplicated models. So if I move it in one, it's going to move for all of them. If you want that decoupled, you actually have to unlink those materials. So now I hit C again, go out of the preview, and then I can just drag and drop this onto the metal, just drag it into the center, apply it as opacity, and now I have a nice gradient from metal to the underlying tool material. So, and this is really cool because you can do this without doing 2 separate passes, going to Photoshop, doing some complicated blending. So this is a nice technique to do everything in one shot in KeyShot. I am afraid there are far more questions than I can tackle. I am going to make a log of all the questions that I have here that have not been addressed, and I will try to get them out to you in some way or another. So, but yeah, this concludes today's session. I hope it was useful. So yeah, see you next month in the next webinar. Have a nice day.